1.7 is linear inequalities. So we have a graph of an inequality. This is the set of all points on the real number line. It's really the only number line we talk about, basically real numbers, right? Set of all points on the real number line that represents the solution set of that inequality. Intervals and inequalities. So we're really just going to do some examples. So if we look at -3 to 5. So open intervals are the parenthesis, closed intervals are the bracket, right? So this means -3 is less, because -3 is not included, than x is less than or equal to 5, because 5 is included. And this is considered a bounded interval because it's between -3 and 5, right? It's not like going forever in either direction. If we look at -3 to infinity, these are both parentheses, so neither -3 nor infinity are included. You really can't include infinity anyway, right? So one way to think of this would be -3 is less than x is less than infinity, but usually we're not going to do that. Usually we will just say x is greater than -3. And this is unbounded because it's going towards infinity, so it'll go on forever. So it's not bounded, it's not closed. If we look at 0 to 2, brackets on either side, so 0 and 2 are both included. So 0 is less than or equal to x is less than or equal to 2, bounded, because if you picture it on the number line, it's, 0 to 2, not going on forever in either direction. -infinity to infinity. -infinity is less than x is less than infinity. You can't include infinities. This is obviously unbounded because it goes on forever. It's not anything closed at all. We can also just write r with the double bar there, like all real numbers. It's not in any sort of notation, but this is also an accurate way to describe that. The notation for inequalities is in here. We're not going to talk about it. We're just more going to show examples, but you can refer to this later if it's helpful. We also have properties. You may hear a Paige screaming in the background. You may not because I have headphones on, but no, she's screaming right now, if you care. So properties of inequalities mostly are the same as the properties of equations. The only one you want to keep in mind is multiplication by a constant. It looks more confusing with the a's and b's and c's, but basically if you multiply or divide by a negative number, you reverse the sign. Sometimes I say flip. So reverse / flip the inequality sign. Okay? So for solving and graphing inequalities, I'm going to show you some examples. So first, let's look at 2x plus 3 is greater than 4. So for the most part, solving, you treat that inequality symbol just like an equal sign, just taking into account that it's there at the end and making sure if you multiply or divide by a negative, you flip it. But otherwise, we just subtract 3 from both sides like we would if it were an equation. We get 2x is greater than 1. Divide by 2, x is greater than 1/2. So we solved it. And now if we look at the graph, basically we're looking at if that's 1/2, all the x values are greater, not included, so it's an open circle, and we'll draw our arrow to the right. For our second one, let's look at 5x minus 7 is greater than 3x plus 9. We subtract 3x from both sides. Again, we're treating it like a normal equation right now. we get 2x minus 7 is greater than 9. And then if we add 7, we get 2x is greater than 16. Divide by 2, x is greater than 8. And if we graph this, similarly, say that's 8, greater than, it's going to be bigger, okay? The last example we're going to do is -4 is less than or equal to 5x minus 2, and 5x minus 2 is less than 7. This is called a double inequality for obvious reasons, right? Because we have two of them. And so what we can do, if we want to, is write this as kind of a combined inequality. So we know 5x minus 2 is less than 7, and it's also greater than or equal to -4, so we can solve it all at once. So we're trying to isolate the x. So first we'll add 2. In this case, it's all three sides. It's not really both sides, right? -4 plus 2 is -2 is less than or equal to 5x is less than 9. We divide everything by 5 now. We get -2 is less than or equal to x is less than, -2 fifths is less than or equal to x is less than 9 fifths. And if we graph that, I'm just going to kind of put it down here because I ran out of space. Basically, what's between -2 and 9 fifths, -2 is included, 9 fifths isn't, and we connect. So that would be bounded, right? The other two would be unbounded. Absolute value inequalities. With the letters, so this works fine, and you can look at this if this helps, but otherwise I'm just going to show you examples to show you how these properties work. So first, if we have the absolute value of x minus 5 is less than 2. So what this means is that x minus 5 is less than 2, and x minus 5 is greater than -2. Okay? And kind of a way to think of this is it's all about absolute values, right? So if x minus 5 is greater than -2, that would be like x minus 5 is -1, x minus 5 is 0, and all of those have absolute values less than 2. Okay? Another way to think of this is x minus 5, absolute value of x minus 5 is less than 2 is numbers less than 2 units from 5. If this is helpful to you, think of it that way. Otherwise, just ignore it and pretend I never said it. So x minus 5 is less than 2, x minus 5 is greater than -2. We can put this together. And x minus 5 then is going to be greater than -2, less than 2. Now we could add 5 on all three sides, I guess. So we have x less than 2 plus 5, which is 7, greater than -2 plus 5, which is 3. So that's our solved inequality. So it'll look like this. You have 3, we have 7, neither one is included, and we connect it, so that is bounded. Now we'll look at absolute value of x plus 3 is greater than or equal to 7. So if you like what I wrote in the rainbow over here, this one technically means numbers at least 7 units from -3, because it's like x minus -3 would be a distance. If that helps, great. If not, pretend I never said it. Maybe even don't write it down or scribble it out. So what this means is that x plus 3 is greater than or equal to 7, and it also means that x plus 3 is less than or equal to -7. Because the idea is that if x plus 3 is greater than or equal to 7, that's like 8 is greater than or equal to 7, 9, 10, etc. If x plus 3 is less than or equal to -7, that's like it's -8, -9, -10, etc. and those absolute values are all greater than or equal to 7. So sometimes plugging in values helps you figure out which way the signs can go. So this, if we put it together, we have, less than or equal to -7, greater than or equal to 7. But the problem with this is that it's kind of backwards, and so you can solve it this way, but it doesn't make a whole lot of sense, right? Because we have a 7 is greater and it's on the left. So I'm going to just solve them separately. So if we have x plus 3 is greater than or equal to 7, subtract 3, x is greater than or equal to 4. If x plus 3 is less than or equal to -7, subtract 3, x is less than or equal to -10. And so this is not bounded, because if we try to graph it like this, -10 is here, 4 is here, less than or equal to -10, both are included, so closed circles goes that way, greater than or equal to 4 goes that way. So this is unbounded, opposite directions, basically not a closed interval, it goes on forever on either side. Now we're going to do an application. It says applications, we're just really doing one application of inequalities. There's a lot of them though. So for cell phone plans, we have one that's $49.99 a month for 500 minutes plus 40 cents for each additional minute, and we have $45.99 a month for 500 minutes plus 45 cents for each additional minute. So how many additional minutes must you use in 1 month for Plan B to cost more than Plan A? Well, first we need a variable. Let's say M is additional minutes in 1 month. So that's what we're solving for, right? So that can be our variable. So as far as an equation, for Plan A, the total would be y equals $49.99 plus 40 cents times those additional minutes M. And for Plan B, it would be $45.99 plus 45 cents times the additional minutes. So for Plan B to cost more than Plan A, we want Plan B to be greater than Plan A. So we can say, well, Plan B was $45.99 plus 0.45 M. If that's greater than Plan A, which was $49.99 plus 0.40 M, let's solve. If we subtract 0.40 M from both sides, we have $45.99 plus 0.05 M is greater than $49.99. Subtract $45.99 from both sides, I have 0.05 M is greater than 4. If I divide by 0.05, it's the same as multiplying by 20, because 0.05 is 1/20th. Either way, we get M is greater than 80. So, as far as answering the question, Plan B costs more when you use more than 80 additional minutes in 1 month. And that's our answer. So again, there's lots of applications of inequalities, and here's just one of them.